Welcome back to my next video, guys. In this video we are going to learn about the electric dipole from the chapter electric field and charges. So please take out your pen and copy and try to make the notes with me. First topic is electric dipole. So an electric dipole is a pair of equal and opposite point charges placed at a short distance apart. Let us show this with a diagram. We will take 2 points and then make an arrow pointing as the moment of force. Let us mark the first point as minus q and the second point as plus q, then the point as p. Let the whole length be 2l and momentum p equals to q into 2l, q into vector q into 2l. Next we will find out the intensity of the electric field at a point on the axis of the dipole. Let us see it with the help of a diagram. We will take 2 points named as A and B, mark them as minus q and plus q. Then we will extend to a point known as P, surrounded by two moments known as E2 and E1. Therefore, E1 is the intensity along the dipole axis, which will be marked as 1 by 4 by epsilon naught q by r minus l whole square, and E2 will be 1 by 4 by epsilon naught q by l plus r plus l whole square, which is opposite to the dipole axis. Therefore, we can write as E equals to E1 minus E2, which is equal to Q divided by 4 by epsilon naught within brackets 1 by R minus L whole square minus 1 by R plus 1 whole square, which will result to Q 4 by epsilon naught R plus 1 whole square minus R minus L whole square divided by that number. We will continue that as q by 4 by epsilon naught within brackets 4 lr r square minus l square whole twice, then 1 by 4 by epsilon naught within bracket 2 ql r divided by r square minus l square whole square. But here 2ql equals to p, electric dipole equals to electric dipole, it will be momentum, the p is momentum of a dipole. Therefore E equals to 1 by 4 by epsilon naught 2 pr divided by r square minus l square whole square. In this case r is very large, therefore we can say r is greater than l, then L square may be neglected as r is very large. Therefore, the equation of intensity will be written as E equals to 1 by 4 by epsilon naught 2p r cube Newton per coulomb. In vector notation, we can write that E equals to 1 by 4 pi epsilon naught 2 pi divided by r cube Newton per coulomb. Next, we will learn about the intensity of the electric field at the equatorial line of a dipole. For that, we have to first draw the diagram of the equatorial point. Let us mark 2 points in the given diagram as A and B. Let us name them as minus Q and plus Q. Let the length of the given point AO and OB be L and L. E1 is the first equatorial moment direction, E2 is the second direction, and the hypotenuse of the given triangle is measured as r square plus root over r square plus L square. So we can write the following equation of intensity as E equals to 1 by 4 pi epsilon naught Q by r square plus L square along BP, right? BP. The point at the top is known as P, and E2 equals to 1 by 4 pi epsilon naught Q divided by r square plus L square along PA. Therefore, E equals to E1 cos theta plus E2 cos theta, which is equal to 1 by 4 by epsilon naught Q by r square plus L square cos theta plus 1 by 4 by epsilon naught Q by r plus L square cos theta. So E is given as 1 by 4 by epsilon naught Q divided by r square plus L square whole plus L square 2 cos pi, and where cos pi equals to BO by BP. As you have seen the highlighted portion, we have to find that highlighted portion over there, which is equal to, the cos theta will be equal to 1 by r square plus L square half. Then we will continue the equation of the equatorial line of dipole as E equals to 1 by 4 pi epsilon naught Q by r square plus L square 2L r square plus L square half, which will result to 1 by 4 pi epsilon naught 2 pi 2QL divided by r square plus L square 3 by 2, which on addition with 1 plus half gives 3 by 2. But here 2QL equals to P, momentum or moment of electric dipole. We will substitute P with 2 pi L. Therefore, E equals to 1 by 4 pi epsilon naught P divided by r square plus L square 3 by 2, and E equals to 1 by 4 pi epsilon naught Q by r cube Newton Coulomb. This is the final result after you have cancelled out the r and L from the given equation. Remember, the L will get neglected as r is greater than L in this case too. Therefore, in vector notation we can write vector E equals to minus 1 by 4 pi epsilon naught vector P divided by r cube Newton Coulomb, because the vector E is anti-parallel to momentum P. Now we will move to our next and the final topic of electric charges and fields chapter, that is torque on an electric dipole on a uniform electric field. So let's, at first we have to draw the diagram of the torque in a dipole uniform field. We have to draw the lines first, and then we will draw the torque. We will take 2 points as given in the figure. We will mark the middle portion as P moment of the dipole as P. Then we will show the direction of the 2 points taken in the diagram, and then we will join the 2 points, which will geometrically form a triangle. The length of the 2 points is considered as 2L, and the height is considered as 2L sine theta, and the 2 points is taken as minus q and plus q. The direction is known as QE, Q vector E. Let plus q and minus q are two charge. L is the distance between the 2 points. Then the two forces, let the two forces are equal and opposite, then let it be a translatory force on the dipole in the given electric field. The two forces are equal and opposite to the translatory force on the dipole in the electric field is 0. And then we can continue by writing tau equals to QE within brackets 2L sine theta equals to 2QL E sine theta, and tau equals to PE sine theta Newton meter, where we will substitute 2QL equals to P, which is known as moment of dipole. In vector notation we can write vector tau equals to P into the vector P into vector E, Newton meter. And P and tau max equals to P, and P equals to tau max by E. Hope you guys enjoyed this video. If you haven't subscribed our channel, please make an effort to do it. If you have subscribed our channel, thanks for doing that. And if you guys enjoyed this video, please share it with others, and please hit the like button too. Thanks for watching.